Okay, so today, to kind of go along with what we learned in class today, we have this graph going on here. And this is a classic greatest integer graph, also known as a floor graph. But you can kind of see this and you can follow along. And if you notice, once you hit this spot right here, just jumps right up to the next one, because remember, every integer rounds down until you hit the next integer. So no matter where you are, you're always rounding down to the next one. So these would basically, and if you look right there, this would basically be a hole here, which immediately jumps up to the next integer. So that's what we're looking at here. So let's go ahead and let's see what everything does. Now, we're going to first look at the classic h and k values. We're actually going to change this. When h becomes more positive, or sorry, when h becomes more negative, in this case it moves right, and when it becomes more positive, it moves left. So that's how it always works. That's why when you see in the equation up above, right here, where it says y equals a floor b x minus h, the reason why this is minus is because you're always going the opposite way in which that you think that you are. If you're making this h more negative, you're going to the right. And I like to think about that as if, well, we're making it go more right because everything is happening in this case 4 units later than it normally would. But if you make it positive, let's say we made it positive 4, everything's happening 4 units sooner than it normally would. And that's how you can kind of think about h, and that's where a lot of people kind of fall apart there. But if I look at k here, k is very straightforward. If you increase k, you go up. If you decrease k, you go down. Those are just very, very common sort of things that happen. Now, the interesting thing is what happens if we change a and if we change b. So let's see what our a and our b values, and those will normally be part of an equation. A will normally be found on the outside of an equation, b normally on the inside. So if you change a to make it larger, if you notice these guys start spreading out, and we'll go to just 2 here. Let's go ahead and make this 2. And basically what is happening here is instead of this, at this point, instead of going and reaching this point right here, which is at 1, 0, that doesn't exist, that's a hole or a hollow dot, it will immediately shoot up 2 units instead of 1. Now, we can see right here that this A basically changes how often it changes. It kind of makes what we'll call a vertical stretch here. And if we go downwards, on the other hand, and let's say we make it less than 1. Now, if you notice, they're all starting to come together and making a very fine line. And as long as it's bigger than 0, but smaller than 1, you'll see that happening. And you can see this occurring all the way across because the jump is just becoming smaller and smaller. And this is called a vertical compression because we're shrinking it down vertically. It's not as wide. And so that's what a vertical compression becomes. And if you make it negative, it goes the other direction. Not that we really care about that. But basically, that's what the changing the A value does. The bigger or the smaller you make it, changes how quickly it's compressed or stretched. And so let's take it to check out B here. Now, if I make B smaller, you notice that it's doing a horizontal stretch, stretching out horizontally, mainly because it takes much longer, and we had this pointed out in class, where it takes up to 3 units, and this is a third as often. So basically 3.3 so before it jumps. So basically 1/3 of the time until it jumps to the next one. And that's going to be consistent throughout. You're always going to see that 1/3 in a matter of 10. So it's not going up nearly as quick. But if we make it bigger than 1, let's see what happens there. If you notice now, we're having a horizontal compression. It's shrinking it down, making these guys really small. And this time it's jumping every 1/3 of the time. So it's jumping a lot quicker. and it will continue to do so. So that's kind of what you can think of. And this is why we like to see these graphs first, because it's very obvious what they're doing. It's obvious when you see the compression vertically and horizontally, or stretch vertically or horizontally. Like if I go with something like this, you're like, well, that's increasing the A value, increasing the stretch value there. And then if you go down, well, you're decreasing, you're compressing it. You're compressing the vertical value. And that's the words that we use in that particular instance. So we'll set this back to 1. Whereas this one, if you make it small, you stretch it. But if you make it big, you compress it. So A and B do very different things, and that's something that you have to keep in mind as you go throughout Algebra 2, is that A and B are in very different places. A, if you notice, is multiplying the function, where B is inside, right next to the x. So if it's not right next to the x, you can kind of expect it to, when it gets bigger, it makes a stretch, and when it gets smaller, it makes compression. Whereas if it's right next to the x, when it gets smaller, it makes a stretch, and when it gets bigger, it makes a compression. So that's kind of what you're looking at there. H and K always do the same thing. H always moves it left and right every single time. Won't do anything other than that. K will always move it up or down. Those are their only contributions in this particular case. So when you're working on these, what you really want to do is you want to consider what's going on, what's happening with all these equations, and how it's occurring. And we'll see this all equations. We touched on this equation today, so I'll put it up here. Function of x equals absolute value of x. We talked about an absolute value function, and we'll get rid of this guy right here. And if you look at this, you're like, well, that's just a basic absolute value function. But let's look at this A, B, H, and K. Well, where would they go? A would go right out front. B would go right here inside this value right here. H would go right next to the x, and K would go right at the end. And if you notice, we'll see it do the exact same things that we just saw with the last one. A, if you increase it, it stretches it. Sorry, not stretches. This does a compression. Yeah, no, this does a stretch. This does a compression, right? And if I go with B, it should do the opposite. Compression, stretch. And it might look like those are doing the exact same thing, but if you remember when we were doing the floor graph, and we'll pull that back up, when we were doing this floor graph, we noticed there was a big difference change, right? So you can notice the stretch, vertical stretch right there, whereas vertical compression right there. Now let's see how the other one works with both of them in the same place. So here we go. Now let's look at this. This is still doing the same thing, right? But it's doing a, this does a compression, a horizontal compression, horizontal stretch. But if you notice, the graphs always are looking almost exactly the same, and that's because they're based on the same values. We have the same A, B, H, and K values. No matter where I move them, those two graphs will always be in the same location. So that's basically how it works. No matter what you do, the A, B, H, and K always, always, always do the exact same things in any graph that you do, any graph that you accomplish. So I hope that you enjoyed this particular one. If you would like to replicate this exact project I've done here, here are your two equations that you're going to need. You got your floor graph, which is your graph right here, your greatest integer graph, whereas this graph right here is just an absolute value graph. And you can see how those change. Remember, if you're ever having trouble with these, always put a floor graph on, because it's really easy to see what's compressing, what's stretching, much easier than any other graph. Absolute value graphs, especially when you start doing A and B, you're like, well, which one's a stretch, which one's a compression, especially if you don't have these guys, right? So keep that in mind as you continue to do these. But yeah, I feel like this is a pretty good video that really kind of puts all the chips on the table here and really will help you out. So I hope you enjoyed it, and I will talk to you guys probably tomorrow. Okay, bye.